Hey, I'm Henrik Desta, and here I represented the charge tape revisited lab for Physics 2. So, the purpose of this lab is to determine how much excess charge is on each piece of charge clear tape while having the charge be evenly distributed across the length of the tape, and then compare it to results found in the previous lab, which was with a point charge. So, for a brief preview of the results, the force of gravity was equal to the electric force, which is equal to 2.943 times 10 to the negative 3 newtons. And the magnitude of the charge on each piece of tape was found to be 2.71 times 10 to the negative 8 coulombs. So for assumptions, air resistance is negligible, and assume that each U-tape made has the same amount of charge, evenly distributed along the length of the tape. So the first fundamental principle that is vital for this experiment is the electric field equation, which states the electric field is equal to K times the charge divided by the magnitude of distance squared times the distance unit vector. Additionally, we use the electric force formula, which has the force equal to the charge of the particle times the electric field. Lastly, there's the gravitational force, equal to the negative of mass times gravity. All of these formulas were vital for determining what the charge of the tapes were. So here's a recap of the first lab, which this one is based upon. My system was one charged piece of tape attached to two walls, and my surroundings was everything else. So for initial conditions, the length of each tape was 0.3 meters, and the masses were both 0.3 grams. For this experiment, we first determined if the charged tape was positive or negative by putting it near a negatively charged plastic pen. Because the tape was attracted to the pen, it can be determined that the tape was positively charged. After putting one tape under the other and slowly moving the bottom one up, the distance at which the top tape moved was found to be 0.02 meters. The charge was calculated to be 1.14 times 10 to the negative 8 newtons, and the gravitational force was calculated to be 2.94 times 10 to the negative 3 newtons. So for the calculations that I made, I first calculated the force of gravity, which is equal to the mass of tape times gravity, and which is equal to 0.003 kilograms times 9.81 meters per second, which is equal to 2.94 times 10 to the negative 3 newtons. And electric force, we assumed was equal to the gravitational force because the tape is at rest, meaning that the forces are balanced. So plugging in gravity for the electric force equation, we can find charge, which we found to be 1.14 times 10 to the negative 8. So here's the code I created. First up, I had the physical constants, which include K, gravity, mass, and charge. Then I created a function for E field using the equations I listed earlier. And then I found a line charge function, which was mostly used to distribute the charge across the entire length of the tape. And I distributed it in 50 segments as I chose n to be equal to 50. Next up, the first part of the code you see from 93 to 103 was basically me just actually creating the tape in the models. And the nested for loop, it has a purpose of creating the electric force and like calculating it for the model. And at the bottom, lastly, we calculate the gravitational force and basically create like all like the numbers and arrows that will be listed in the model, which you'll see now. And here you can see that the magnitude of the electric force is a lot smaller than the magnitude of the gravitational force, which means that the charge I inputted, which was from the point charge, is not that accurate. So basically what I did was I guessed and checked until I got electric force equal to the gravitational force, and the charge I found to make that happen was 2.71 times 10 to the negative 8 coulombs. So possible errors for human, the charge tape could have been made with unevenly distributed charge across it. The charge tape could have been made with unequal charges. For computer errors, I could have incorrectly created the computational models in GlowScript. Discussion 1. What if? What if you had models? What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated values of the charge you get when you use your experimental data to produce a point charge model to the value you got for the line charge model. So the point charge model yields 1.14 times 10 to the negative 8, as opposed to the line charges 2.71 times 10 to the negative 8, which is a 57.9% difference and pretty significant. So the why these estimates differ, the estimates differ because the way in which they are calculated are not the same, and the line charge is likely more accurate and closer to the real value because it resembles what happens in the real world. So in conclusion, we determined how much excess charge is on each piece of charge tape using a line charge model and compared it to the point charge model. And the line charge model had a different outcome compared to the point charge model. The line charge model was a much more accurate way of depicting the charge and led to overall better results. And the experiment led to a lot of interesting information that shows anyone that looks at it a little bit more about how charges interact. Thank you.